Yeah, good morning. I hope you can see clearly the writing on the board. Here today we are going to look at time complexity function of a certain algorithm. When you are given a list of items, you ask the computer to sort out those items for you. There are different algorithms, there are different computer programs the computer will use to sort out that data or that list of items you have. So what we are going to look at here, we are going to have a short list of numbers. 1, 2, 6, 2, 5, 4, 9, 8. And we'll ask our computer to sort out these numbers in ascending order. That is starting from the lowest, which is 2 in this list, and then to the highest, which is number 9. You got certain algorithms they call insert, exchange sort, quick sort, heap sort, and many others. And they are all different, the way they do their sorting process. So they are all different, they do sorting differently. So mathematicians and computer scientists have come about to investigate these sorting algorithms, and they have worked out the efficiency of these sorting algorithms. They know them already, so they know for a particular piece of data, this type of sorting algorithm is more efficient than the other one. So let's assume we don't know. For this list we have here, so we want to use this insert sorting algorithm to sort these numbers in ascending order. And the insert sort, how does it work? Let's say you have this number here, these numbers here, 6, 2, 5, 4, 9, and 8. There's 0, 1, 2, 3, 4. Because this is what the computer has. It has cells, memory cells, or memory slots where they keep information. Yeah? And then, if you are using this insert algorithm, the insert algorithm, it will not look at the first number. It will look at the second number. It will assume the first number is already in its right position. That's what it assumes. Say like you have a piece of cards, playing cards, deck of cards in your hands. Say all these numbers are being represented by the cards you have. So, as a human being, what do? You look at these cards. Oh, number 9 is here. Number 8 is here. You will just take where number 2 is. You put in the place of number 6, and then you bring the next one, which is 4, next to 2. You bring 5. You can see with your eyes is much easier to do, but the computer don't work that way. It doesn't have eyes to see these numbers. It can recognize them, their positions. It recognizes the positions and the memory slot. So that is why it works this way. If you look at the second position here, it assumes number 1, slot 0 is already been sorted out. It will then compare this slot and this slot, this memory slot and this memory slot. It says, 2 and 6, which one is bigger? 2 is big, 6 is bigger. Then you say, oh, then I need to swap. Then it will swap. 0, 1, 2. Now 2 will come here and 6 will come to this position. Then 5 will still be here. And blah blah blah. It will say now, okay, I've sorted these two, the first two. So let me see now. 5 and 6, which one is bigger? It says, oh, 6 is bigger. Then 5 needs to go to that way. This is how insert algorithm works. This is how it works. until it completes the whole list. So I've written the algorithm at the back of the board so that we're going to analyze the efficiency of the algorithm. This is not a computer science class, so I don't want to go into this. This is for computer science students to go into this. So now let's see what the code says. This is the computer program. We have to sort out that list using the insert sort. What we want to do, as I said before, we are trying to find the time complexity. That is the efficiency. In short, it's much more than that, but in short, that is what we just said. The efficiency of the program. This is a computer program for the insert algorithm. And here we are going to assign a letter to the operations. That's significant operations, the big operations the computer does here. So those variables, we're going to assign some value to them. So now let's see. We've numbered the lines so that it will be easier for us to work out what is happening on every individual line. From line 1, we have the inputs L. This L is a list. That list you saw before, the list of numbers. Okay? It's a list of N. We don't know how many numbers. We assume here that we don't know how many numbers. There it was about 8 numbers, 5 numbers. So a list of N. So for I equals 2 to N, so from the second position to N, do. This is a for loop. That's why it has a for. I equals 2, as I said before, with the insert algorithm, the computer will start to look at the second memory slot, not the first one. With other algorithms, they will start from the first memory slot. So that's why you have here for I equals to 2 to N do. Then we have this assignment. X is assigned to L of I, and Y is assigned to I minus 1, while this is this, and while Y equals to 0, Y greater than 0, and X less than the length of Y, and L is Y plus 1. These are all assignments. As I said, this is not a computer science class. We don't go into this too much of it. Yeah? We are just looking at the mathematical side of it, which is the complexity function we are trying to find out. So now let's see what every single line here is doing. And then when you look at line 1 just gives us an information that L is a list of length N. That is it. But what is line 2 doing? This is where the program starts. The computer starts to run the program from here. Line 2 is a for loop. So let's say this function this list we are asked to find its time complexity. Let's say it's F of N. That list of number, L of N. F of N, yeah? So now, for line 2, the program will start from 2 to N. And since this is a for loop, it will be doing this over and over and over again till N minus 1 times. So we have for line 2, line 2, to do it N minus 1 times. Yeah? And then we'll come to line 3. How many assignments do we have in line 3? We have 2 assignments. You know, when you see this arrow here, we have Li is assigned to X. I minus 1 is assigned to y. Don't worry about these letters. These are just placeholders. But as I said, since this is not a computer science class, we don't want to go too much into that. We are just doing the mathematical side of this. Yeah? So line 2, how many assignments do we have? We have 2 assignments. And since this program is running at I minus 1, what did I say here? I said n minus 1, sorry. Should be I minus 1. I minus 1 time. Line 3, again, we have 2 of these. So it's going to be 2 times minus 1. This is n, sorry, n times. And then what happens? Line 4. Line 4, this is line 4, yeah? And this is line 5 here. Line 4, you can see line 4, there is no assignment here. This is just a while loop giving us information that when y is greater than 0 and x is less than L of y, we do. So while this condition holds, then do what? We do line 5. Line 5, then we are assigning y to L of y to this, and x to L of y, and y minus 1 to y. But how many assignments do we have? We have 1, 2, 3. You know, when you see these arrows, they indicate assignments. That's so line 5, we have 3 assignments. Line 5. We got 3 assignments of y. But we are told that y here is initially given the value I minus 1. I minus 1. For this while loop to hold, y was given the value I minus 1 as the initial value. But we got 3 assignments here. So then we got to add up these assignments. Sorry about that. This is now I minus 1. Let me write it properly. We are summing those 3 assignments. So we have them as the summation of 3 I minus 1, because it's 3 assignments. So we have and I minus 1, I equals to 2. I get it right? Yes. First n, so I equals to 2. You know, before I mentioned that, here you see it starts from 2 there. So it should be 2 here. Start from 2. Insert program. Insert algorithm. Start from 2. So we should have 2 at the bottom here. I equals to 2 to n. To n. I equals to 2 to n. Yeah? So this is what we got. Now, the program will come to an end. Line 5, after line 5, n do, and the output. The output, what we get in the output, when you look at those numbers, it will then sort them out. 2, 4, 5, 6, 8, 9. This is what you get as the output. Line 8. This is what you finally get. So now, let's find the time complexity of all these functions to add them together. So I'm going to erase this. Now I can, it's part of the program as well. I hope this thing is clear. The board is too far away. It's better. It's too far away. So now we have Fn, line 1, line 2, we did have n minus 1, plus line 3, plus 2 into n minus 1, and then line 5, we have this summation, I equals 2 n 3 I minus 1. Good. This is what we need. All that is left now is just algebra here that is left. So this is n minus 1 and 2n minus 1. You combine these two, you get 3 into n minus 1. There is a 1 at the front. 2 combine, you get 3 into n minus 1. So this one here, we got to do some manipulations here, because when you are doing summation of series, this is another topic, we haven't covered it yet, summation of series. Normally you have, at the bottom here, you have your series, you start from the first number, that is I should be equals to 1 to n. And if you are now summing the first natural numbers, and it's in this form, you will have n into n plus 1 all over 2. If you are given 1, 2, 3, 4, blah, 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 and you're asked to sum up these numbers, the sum of the first natural numbers, this is the formula you get. So depending how many numbers you have, represents n. If you have 10 numbers, it's going to be 10. And you start from the first one, maybe you start from 2, so 2 to 10. Or you start from even the first number 1 to 10. This is the formula. We know this already. So, but we want this formula now, we want this one to fit in here, so that it will be much easier for us. But we'll go 2 here, and this should be 1. So what do? We need to do some adjustments. Yeah? So this one now will become, since we have, let's take out this 3 here, because this 3 is a constant. So 3, we have n, I equals to 2, and I minus 1. So if we shift this, we'll reduce this by 1, it's now going to be 3 summation of I equals 1, and then n now will be minus 1. And this will still be I. Yeah? When we adjusted here, we remove 2. Now we start from 1. So the formula becomes straight away like this. So here, we are now going to write this one in the place of this. This is another topic anyway. We call it summation of series. It doesn't belong to this side. 3 summation of n minus 1, I equals to 1, I. So now all done. So we just need to know what is this. This is 3 into n minus 1 plus, this thing is going too long. I want to cut it short. Now we know how to work out this. Yeah? This is 3. We have n, but our n is n minus 1 instead. And n minus 1 plus 1 all over 2. This is what you have. Yeah? Remember that formula, n into n plus 1 all over 2. But here our n, instead of n here, instead of n, we have n minus 1. So that's why we have n minus 1 in space of n. And n minus 1 plus 1. Okay? So now you have 3 into n minus 1 plus 3 all over. Let me just leave it like this. 3. So n minus 1 plus 1, this should be n. So you have n into n minus 1 all over 2. Yeah? This is algebra anyway. So now you have n minus 1, n minus 1. Yeah? So can we do something here? So you have 3 and you have 3 here as well. So 3n minus 1, factorizing 3n minus 1. This now you have 3n minus 1, you have 1 there. Plus what will remain here is n all over 2. Because n minus 1, we've sent it out here. The 3 we've sent out here. So what is left here is just n all over 2. Okay? So this will give you, now we've got to do this as well. This now will give you 3 into n minus 1 and 2 plus n, then all over 2. This is what you got. So now if you look at this one, if you want to expand this, n times, let me just say n plus 2. N times n is n squared. That's the biggest you can get. Well, the biggest you can get here, the unknown, is n to raised to the power of 2. Okay? If that is the case, then you can say, thus f of n is less than or equal to all this 3 all over 2 n minus 1 into n plus 2. And then I've already said, when you expand this, you'll get a maximum power of 2. So therefore, the time complexity of this algorithm is in O, big O, n squared. This is your final answer. Thank you for watching. This video has been long.